Quadratic function gives us this handy dandy parabola. So we are going to talk about, it's on my computer so you can't see it. So we're going to talk about translating that, which means taking your parabola and moving it left, right, up, and down, and also making it wider or skinnier. Okay, and we have specific words for that, but it's later. So moving on. The first thing we're going to talk about is what happens. Okay, so the other thing, the parent function is always x squared. So x squared always, y equals x squared always looks like this, and they have it drawn right here. And that it's helpful if you know that, because x squared always is 0, 0, 1, 1, negative 1, 1, and so on and so forth. That is, and then 2, 4, and negative 2, 4. That's always the parent function. That is like the most basic quadratic function you can graph, okay? Everything that we do to the quadratic equation after that changes this original one. Starting with adding or subtracting a number. If you are just adding or subtracting a number, we reference that as k. So this is a k, and in this case, k would be a positive 1. That's what we're adding to our function. And that moves it. Let's see how it moves it. If I plug in negative 1, what's negative 1 squared? And if I add 1 to it? 2. If I put 0, 0 squared is 0, add 1 to it? 1. If I put 1 in there, squared is 1, 2. So look what happens. 0, 1, 1, 2, and so on. So it takes that exact same parabola and does what to it? Where did it go? It didn't make it skinnier. It just moved it up. It just moved it up. So when k is 1, the translation, k is k, when k is a positive 1, the translation that happens to the original graph is it moves it up 1. Very good. If it was a positive 2, it would go up 2. What happens? Okay, look at the second example. X squared, that's our parent function, and it's graphed in there. X squared minus 7. What do you think is going to happen? It should go down 7. But just for the sake of this, putting in 0, I get negative 7. Putting in negative 1, square it, gives me 1. 1 minus 7 is negative 6, and so will this be. So 1, 2, 3, 4, 5, 6, 7. And I'll do my best to draw it exactly like it is, because it doesn't actually move the arcs. It's the same thing, just slides it up or down. So that translation moves down 7 units. And I'm just going to call them units, but just know that that's notches in your graph, okay? So if we have a number outside that we're adding or subtracting, that's what moves our parabola up and down. All right? Any idea what's going to move it left or right?
The x or the square.
Okay, this is the tricky part. Check this out. In this paper here, right here, it shows us if you have something in the parentheses with the x, but it has to be included in the squared. And this is the formula. So this is kind of tricky, because in this formula it is x minus h. So in this case, oops, you guys can't see that. In this case, h is positive. Okay, when it's a minus h, that's when h is positive. And if I'm moving left and right as far as the x-axis, if it's positive, what way does x go?
To the right.
To the right. And now here's the tricky part. If it is x minus a negative h, what does it end up looking like? That's plus. So when you have a plus in there, believe it or not, h is actually negative, and you will be moving left.
So it's like opposite?
So it is opposite. But that's only for the one in the parentheses. The other one outside the parentheses, positive is up, negative is down. Okay, but in the parentheses, it's backwards. Okay, so let's turn the paper over, the back of the first page, and show you what I mean. What's really cool about this is that they graph both the parent function, the original x squared function, and then this one. So h is positive 2. I was going to write it there, but I have it right there, so you don't need that part. H is positive 2, which means,
It's the opposite.
remember, it's the opposite, right? That's the hard part.
Yeah, that's weird.
It is weird. And it's opposite because the formula is minus. Okay? So h is actually a positive 2, which means we are translating 2 units right.
So then,
And then on B, when it is plus 1, what's really happening there is x minus a negative 1. So h is really negative, and that's why if you look on the graph, it slides it over, translates it over 1 to the left. We have 2 more examples, but they don't even give you the graph because they figured 2 of these, you can handle that. So take a look at this one right here, 2a down here. What is h? It's a positive 3, correct? And if it's positive 3, that means we're going this way. So 3 units right. And then in B, it's plus 2, which really means that h is negative 2, and it is 2 units left. So we currently have 2 types of transformations, up and down and left and right, which really, if you think back to geometry, that's both translations, right? You translate up, down, left, right. It doesn't matter. But up and down is this number, and left and right is this number. And they're going to refer to them as h and k. So this is k, which is positive 2, and this is h, which is positive 3, even though it's a minus sign, because the minus is your formula. So take a look at what happens to the parent function here. We could probably guess if k is up 2, that's going to go up 2, and h is going to go to the right 3. But check this out. What's my vertex? Because my vertex is so the coolest thing about this is I can just look at that equation and know my vertex. Instead of, remember yesterday when we got it in standard form, we would have to do the negative b over 2a and calculate it, then plug it in to find your y. Right here, I know my y is 2 and my k, or my x of my vertex is 3. So that's what's cool about this way to write it. But how did we translate it? So 3 units left, 3 units right, and 2 units left. Up.
if you say up 2 units to the right 3, it doesn't matter which way.
No, you could say up 2 units first and then to the right 3 units. All right, so let's look at, yes, Logan.
If, like, k, or the number on the end, if it's negative there, like, it doesn't change, right?
No, then it is negative. It is negative 1. K is the sign with the number. Yep, and H is the opposite. So K is negative 1 and H is negative 3. So take a look at what happened to our vertex. Down 1 to the left 3. So our...
F(x) is the first one? Like
What's that?
Original one? F(x) is the original one?
Yes, this is, yeah, that's your the parent function, they like to call it. It's the f of x equals x squared. And so our vertex would be hk or -3, -1. But what happened to our original function? We moved
Down 1 unit and to the left 3.
very good. So we moved it up, down, left, right. Everybody good on that one? Okay, if you turn to the next page, here's where we're going to talk about a dilation or a reflection. Remember a dilation, and I don't really necessarily like the word dilation, but that's what they choose to call it. It just means that your curve is either going to be skinnier or fatter. All right? And here is what controls that. This is the number in front of the x squared. That's what controls that. And if we look carefully, if a, the absolute value of a, is greater than 1, so whether it's positive or negative, if that number is greater than 1, like a positive 1 or a positive 1.5 or a -3, what happens is it stretches vertically. Now, when you think about stretching something, what happens? Does it get skinnier or fatter?
Skinnier.
Skinnier. So the bigger the A is, the more you stretch it, and it gets skinnier. Okay? Now, if A is smaller, so between 0 and 1, so a fraction or a decimal, they call it compressed. They squat it down, which happens, then it goes wider. All right? And if it's negative, oh, we'll talk about that in a minute. Sorry. So here we go. Now notice they take out the h and k. They just put 4x squared. If I put that in there and we fill this out, you can see what happens. -1 squared is 1 times 4 is 4. So I've got -1, 1, 2, 3, 4. -1/2. Ooh, what do I get when I square -1/2? 1/4. And what do I get when I take that times 4? 1. So -1/2 is 1. That's halfway between there. 0 is going to be, in this case, 0. So that didn't move because we don't have an h and a k, right? And this is going to be 1 and this is going to be 4. So it gets stretched. And I'll put in here skinny. Is skinnier with an I or a Y? Yeah. I'm pretty sure I spelled that wrong. Pay no attention to that.
Wait, let me see.
Is that right?
Yeah.
Okay. Rock on. I'm still awesome. All right. Moving on to the next one. Look what they did here. Not only do we have a coefficient in front of the x squared term, now we still have that extra number. What is that? Well, we can just plug it in and see what happens. All right. Put 0 in. 0 squared is 0. 0 times 1/2 is 0. But 0 minus 3 is -3. Put in -1. -1 squared is 1. Half of -1 is 1/2. And 1/2 minus 3 is -2 and 1/2. Right? Put in -2. Square that, I get 4. Half of 4 is 2. 2 minus 3 is -1. And hopefully you guys know that that's going to be the same. So let's plot these. 0, -3. -1, -2.5. And -2, 1. I should move that one out. So it's hard to see on here, but it is wider, right? We call it a compression. So we compressed it And we translated it too. What happened to our vertex? Where did it go? Down 3. Yeah, Logan.
What's the little like A equals thing?
Oh, thank you. A would have been 1/2. Thank you.
Okay.
And over here, A would have been 4. Sorry about that. Good question. What happens if A is negative? Thanks for that beautiful transition, Keaton. That was awesome.
Like what?
I wish. It is, believe it or not, if A is negative, it's a reflection. So it flips it. We know that. We knew that already, right? Because what happened? Think back to when we said if the number in front of the x squared is negative, what happened to our parabola? It opens downward. That's what it is. So when A is negative, it just flips it down. Okay? So here's the original parent function. X squared is right here. So what happens to the +2? It moves it up 2, but then when A is negative, it flips it. But see how your vertex still goes up 2? But now we flip it and it opens downward. We reflect it. So the translation of the graph is up 2 units because K was 2, right? And a reflection over the X.
Is that always going to be the reflection?
Yep, it will always be over the X. So now you get to flip this last page over. And I know. So we have lots of things happening. We are moving left and right. We are flipping, reflecting, and we are going compressing or stretching, right? Lots of things to think about. It does feel like a lot, but it's amazing how much this will apply to some other concepts in math, all right? So here, this is a multiple choice. It's a little foggy. Sorry about that. But you will have questions like this. This is out of Alex, I'm pretty sure. Right here. This is out of Alex. Because it gives you 4 options and asks you, what did you do to the graph? Which one is it? Well, first of all, do you see how the vertex is down 4? So I can eliminate those 2, right? Now we just have to determine, and they're both negative, so that didn't help, right? They were all negative A's. Okay, but is this going to be a stretched curve or is it compressed? So here's what I look at. I'm going to look right here. Is it out 1 over 1? Pretty. It is not quite, but let's see. What's this one?
Is that like 2 down 4 over 2 down 4?
It's hard to see. I wish we could see the graph lines. And on Alex, you will be able to see your grid lines, so that'll be easier. I am pretty sure it is 1/2. No, excuse me. I'm pretty sure it's -2. Because 1/2 would have to be out here farther. Gosh, I don't know. It's hard to see without the grid lines in there. It's easier on this one down here. So it's got to be, I'm thinking it's this one, but hard to see with the grid lines. Let's look at this one because it's way easier. Because you can see, well, first of all, so it's got to be, you can eliminate these 2, right? It's just the top to my pen. And then, well, hello, it goes down, right? So this has to be negative.
Wait, what do you mean it goes down?
Opens downward.
Ah.
But then the other thing, it's 1/2, because check this out. Over, up a half, over, up a half, instead of 1. So it's got to be C.
So if it opens downward, then
It's got to be a -A. The number in front of x squared has got to be negative. All right? So let's think about, it shows you a whole bunch and it talks about all the things that A, H, and K do. But let's just look at these two examples here and kind of just write down what we know those graphs would do.
It would be down 3 in reflection.
Okay, so right, it would be translated down 3. Okay, because of this, right? Somebody already said reflected.
So how do you know they're reflected again?
Because this is negative.
Over the.
Okay.
Yep, reflected over x-axis. And then I heard somebody say it. See how 2 is bigger than 1? So what happens to our curve? What happens to our... It is stretched. Nope. Stretched means, imagine taking a string and stretching it. It gets skinnier. Yep. Okay, now check out this one down here. We have an H, we have a K, and we have an A. I know. Let's first start with our H and K, because what happened to our...
It translated up 1.
And...
To the right, or to the left.
And left 2. Yep, up 1, left 2. That's how we got that.
Because of that pop. Okay.
Yep. Because this is actually x minus a negative 2, right? Then, what does our A end up doing to it? 2 things, right? It reflected.
And then doesn't it also stretch it?
And a lot stretches it. Thanks, I'm glad that was recorded.
Oh, Stretches.
Stretches. All right. We're done with our lesson, so now we're going to go on to our assignment. Good luck.